Next, we're going to look at the two-proportion Z interval. The purpose of this interval is to estimate a difference in population proportions, P1 minus P2. This procedure is based on the sampling distribution for P1 hat minus P2 hat, and the conditions are consistent with that. We have to have two independent SRSs from two distinct populations. Each population must be at least 10 times the respective sample size, and the number of successes and failures in each sample has to be at least greater than or equal to 10. So this is the number of successes in sample 1, this is the number of failures in sample 1, number of successes in sample 2, number of failures in sample 2. And those all have to be greater than or equal to 10. The formula is based on the sampling distribution, P1 hat minus P2 hat plus or minus Z star times this big standard error expression. And it's not even worth reading off, it's too long. On the calculator you can find this at stat test B, two proportion Z int, and it's actually much easier to do on the calculator than it is to do by hand. Let's look at an example. We have 1,075 volunteers randomly assigned to two groups. Group 1 is asked the question, is the death penalty applied fairly or unfairly in the United States? Group 2 is asked the question, is the death penalty applied unfairly or fairly in the United States? The group sizes, number of fairly responses, and the proportion answering fairly are shown in this table. And we want to estimate the difference in the proportions of people who would answer fairly to each question with 95% confidence. And here's how we do that. First, we define what we're looking for. The difference, P1 minus P2, is the difference in the proportions of people who would answer fairly to each question. That's question 1 versus question 2. As far as the conditions go, we have two independent simple random samples based on random assignment to treatment groups. This is an experiment, and when you have random assignment to groups, that usually satisfies the first condition. Secondly, our populations are much larger than 10 times the sample sizes, and the number of successes and failures in each sample is well above 10. You can see those values here, and they're all much, much greater than 10. The confidence interval, using the formula and the plugins, 0.5307 minus 0.4405 plus or minus 1.960 times this big standard error expression. It simplifies down to 0.0304. This difference simplifies down to 0.0902. And when you simplify it all down further, your margin of error is 0.0595. Your interval is 0.0307 to 0.1497. Margin of error is almost 6 percentage points in this situation. And then we write our conclusion. I am 95% confident that the true difference in the proportions of people who would answer fairly to each question is contained in the interval from 0.0307 to 0.1497.